Good morning or good afternoon to everyone, depending on where you are. Thank you for making time for this continuing education session. For those who are who have not heard of DIME or DIME Analytics, I'm going to give a quick 1 minute overview and then Ben can take over with today's session. So the DIME Analytics team is a team within the DIME department where we develop and best practices around working with research and data, especially in the field of impact evaluations, and also work on building capacity around those best practices. The continuing education series is a part of the capacity building effort where we host sessions, usually once a month, on different topics that are of interest in working with data, or also collecting data on the field. Today's session is on working with geospatial data in Stata. So this is applicable beyond just the realm of impact evaluations. I hope it's useful for most. I will let Ben take over and tell us more.
Okay, thank you, Rashni, and welcome everybody. I'm seeing some familiar names. I can't see a lot of faces. Unfortunately, the interface on this is a bit weird and I can't see everyone at the same time. So if you're waving or smiling, I can't tell. Please feel free to either type in the chat, which I think I can see, yes, which I can see, or to raise a hand on the sidebar, which I think you can do in the participants panel. We'll monitor those, and if I'm really ignoring you or a question that you want answered, please feel free to just unmute and say hi. I don't mind at all being interrupted, and I'm happy to stop and take questions for things that are challenging. So this is a very straightforward class. It is meant to be hands-on, so if you're following along at home, feel free to open Stata and go ahead and do the work that's in here. You'll definitely get the most out of the class if you do follow along in real time. I'm going to walk you through the process of building up a map in Stata using publicly available data and information. It's a good lesson here because there's very little new concepts to introduce you to. Obviously, everyone here knows what a map is. Here's a map of a place that most people recognize very quickly. And maps are useful. I don't think it surprises anyone to see that this is a fully booked session and that people are here on time and are excited to do this because maps are awesome and very useful, but they're actually pretty hard to put together if you don't have, a guide to the technology that you're going to be using. There are lots of terrible ways to make maps. You can load up an interactive editor like ArcGIS if you have a Windows machine, or you can use one of the other softwares like QGIS if you have a non-Windows machine. The issue with a lot of these is that, of course, they either aren't reproducible at all, meaning that you spend a lot of time manually piecing together the information that you want to show in your map. Or if they are reproducible in some way, they require a code language that you have no experience with and isn't integrated with the statistical software that you typically use. For example, I know you can do various kinds of shell scripting, or I forget the language that you can do for ArcGIS since I never use it. But the code is not operable with the materials you already use, obviously, and then the data itself is either coming through shapefiles or spreadsheets. Again, not the data that you're typically using in the statistical software that you're doing the rest of your work in. So this session reflects all the knowledge that we've gained in putting maps together here in DIME over the years, both to create beautiful reports, to look at the way that work in the field is going in real time, which is an especially useful implementation of having reproducible code set up as data is updated, is coming in from the field. Checking the quality of data. We've seen plenty of situations where you have enumerators walking around where they should be, and when you actually get the data in the end, it's somewhere in the middle of the ocean, and this isn't useful. So continually checking both completion, quality, and then of course, doing analytical work using geospatial information, such as precise locations in some cases. That'll be the hardest thing to do in Stata, so I'm not going to teach you to do a lot of stuff with that. But we can start to approach it. So we're going to make this map of Kenya with one click. We're going to write up all the code that we need to do it from scratch. There's lots of ways to change these materials. All of the things on the map that you'll see are called attributes. There's a number of them here. We have the basic elements that we're going to look at are the base map here, which is the geography in the background, the political geography here in particular. We're going to add 3 types of features, and we're going to define them pretty broadly to be basically points, lines, and areas. You'll see that the areas here represent, I think, national parks. The points are public campsites, according to one database, and the lines are going to be the major roads here. So it's easy to stack these elements up. Stata is somewhat limited compared to other softwares in the number and complexity of these features that it can handle. But as you can see, for a pretty, reasonably complex and integrated set of data here, you can get, excuse me, you can get the stuff that you need in that map, and you can do it pretty easily once you understand the software. So these are the typical commands that you're going to need to do GIS work. The first 2 are the only ones that we'll need for this session. SHP to DTA, shape to DTA, takes shapefiles, which is the file format that geographic information typically comes from when it is posted online, and converts that into Stata datasets. The datasets that you'll see won't make any sense, is they won't be usable in the normal sense of loading them into Stata and doing analytical stuff, but they will work for plotting the geographical information. spmap is the main Stata command that we'll use to actually create the maps. I'll say graphing the maps here because it actually just uses the regular graphing architecture. And then the other commands here are commands that you can use to make analytical approaches using some of that material. For example, you can make evenly sized grids if you need to do some kind of grid sampling or doing other kind of checks for randomization completion over space. GeoDist will calculate the distance between 2 points that are on the map for you. This is very useful when you're talking about treatments such as distance to an event, distance to a city center, distance to a market, plenty of reasons why you need to calculate that. And you can't use, even though you have latitude and longitude, you can't use Euclidean distances between them for these reasons because of the curvature of the Earth, so this does it correctly. Merge poly will let you change things, so if you have multiple areas, multiple plots of farmland, for example, to combine them into single larger plots. And geoInPoly is a useful command to see if a point is inside an area that you've marked out. So these are all the basic commands. Things that Stata cannot do well are things that you may want to do and may turn to other software to do, such as measuring distance from a point like a household or something else to a line, such as a road or a river. Stata cannot do that. You'll have to go somewhere else to get those features made. And other typical mathematical operations on these shapes tend to be pretty difficult. So areas of polygons are not really going to come out for you. Shortest distances along networks, definitely not happening. So again, there are limitations. To do anything that's truly natively geographical, you'll want to go to a software that has that bit built in. But we can get the basics done here, and the basics are often more than enough for the outputs that we want to do. So our first step in any map is getting that base map, getting the actual the familiar political and geographic boundaries of the world that we know and the one that we work in. So as I said, we'll be going to Kenya. The most popular and complete resource for these is the Diva GIS website. They have what's called GADM data, which is the database of global administrative areas. These are political boundaries from the national level all the way down to usually 3 to 5 subnational boundaries, depending on the political divisions of the country. They're very good in most cases. There are obviously a few cases. I believe everyone here is an internal World Banker. So there are a few cases where you cannot use these in World Bank publications because of areas with disputed boundaries, which are not approved. The Geospatial office, one of the offices has the has national boundaries that are approved by the World Bank. These are not them. So if you need to do it for a publication, you need to find and acquire those files. But for most things, this will work pretty well, at least for reports and stuff that you need to work up internally. So let's go to Kenya. Go ahead and select the, if you go to the GIS website, select Kenya in the country dropdown, take the administrative areas. They'll also have a range of other information depending on the country and what materials are available. And it'll take you to this website where you can download the administrative areas for Kenya, and that'll have all of the subdivisions in that material. The first thing you need to do is convert that file that you receive, and you'll actually receive a number of files in that download, from shape files, which are .shp files, to DTA files that are native to Stata, which you know as DTA files. When you open up, you'll actually download a folder from that material. It'll come as a zip file, and inside will be a number of different pieces. The ones that we're interested in are the ones of this form, are the Kenya, so it'll come with a 3-letter country code, and then administrative data sets, and then the level. So the level 0 ones are the national boundaries. That is one polygon for the national boundaries of the place you've downloaded. Level 1 will be equivalent to U.S. states. Level 2, U.S. counties. We don't go below that, but lots of other places do. They have Kenya has national, region, county, sub-county, and I think a locality below that. So Kenya actually has 5 administrative regions at least that you'll get from downloading this package. When you run the shape to DTA command on one of those files, so here we're selecting just the national administrative boundaries, we create 2 DTA files right away. So what you're going to notice, of course, is that you're going to need to be quite organized about how you name and store these. Otherwise, you'll make a lot of maps that don't make any sense, and you'll lose your materials really quickly. So as usual, we use absolute file paths starting from our globally stored directory, and we store them in well-organized data directories to contain this information. So you create 2 files. The first is the database, and the second is the coordinates. I always name them explicitly when they're converted to DTA files so that we can keep track of which file is which. And this is where the Stata DTA format is quite different from the way that the shapefile itself is stored. So the shapefile actually combines 2 things. The first is the coordinates that are used to draw the shape. So the actual point by point, the entire line boundary of the mapping area that it describes. That's what goes into the coordinates.dta file. If you open this up, it is very boring and not very useful. It is literally a list of the points that are going to be drawn as the boundary of the territory. So there will be a variable called X and a variable called Y, and it'll be a set of latitude and longitude points. And then there will be an ID variable that's used for technical indexing. So this is an utterly useless DTA file to you, but it's obviously necessary to draw the map that we're going to look at. The database is the second part of the shapefile, which if you open it in something like ArcGIS or QGIS, you'll see as a table of attributes that are corresponding to the different areas described in the shapefile. In this case, for Kenya administrative level 0, it's also going to be a very boring and useless data file because it only has one entry to correspond to the one polygon. It'll say it's a national boundary and it's Kenya. So while this isn't useful at this stage, we will need the database. We will need the database file whenever we have more than one polygon, and we'll use that as the core data set to merge on things like attributes for the administrative regions we're looking at, for example, states or counties in these countries. And we can use that file as a regular data file. It is a tidy data set where each row represents one of the entities at the administrative level you selected. So if you open the administrative level 1 for the United States, you'll get, like maybe they have an admin 1 for regions. Anyway, I'm going to assume it's states. You'll get a 50-point data set, or 51 if it's lower 48 in DC, 49 if it's lower 48 in DC, obviously. And each row will represent one of those entities. It'll have information such as the area, the population, and it can merge easily to other information that you may have, such as the poverty rate, the number of samples you collected, the spread of an infectious disease. Whatever those informations you have can merge onto that data set very easily, as long as you have the IDs or the names correctly. The options that we're specifying here are just standard for translating this stuff. We want to allow Stata to replace the data sets, and we want to generate an ID, and we just want to call it ID, capital I, capital D. Don't change that. Once you do that, I don't show the way it looks here, but you just simply get those two materials. And to draw Kenya, very simply, using the national boundaries that we just downloaded from the admin 0, we need to have the database file in active memory in Stata, so we need to use it, because this is the ID that it will use to search for polygons in the coordinates data set. Then we simply call the spmap command using the coordinates data set, and we tell it the name of that ID, which is capital I, capital D. It'll draw that boundary for the country of Kenya at the national level in the graph window, just like any other Stata graph. And you could export that using the graph export command, just like you would any other picture you would create. So this is beautiful. It's also very easy, and it's relatively quick, unless you start to get very complicated seaside regions, because these little inlets and outlets can be pretty intense, and so it can occasionally take time to graph them slowly. Again, if you're graphing India, for example, it'll spend a very long time drawing some very small, complicated islands that are way off the coast. You can exclude that by going into the data set that you've used and dropping the observations you don't want to see appear or that are taking a long time to render. And Kenya alone spends about half its time graphing Mombasa, so the rest are big straight lines. It's great. Okay, as I said, it's just two commands. It's very simple to get the basic information set up, and this is going to work for just about any level. This is called the base map, and so when spmap refers to using the base map here in the help file, which I'm sure you all have open already, it's referring to that coordinates data set that is the unit of observation for the database, and what we're going to talk about is the unit of observation for the map itself, even if we add other things on top of it with different units of observation, such as lines, points, polygons, and so on and so forth. So let's go ahead and slowly build up from that base map to a map that tells us more information about the things we're looking at. Let's go back to Kenya. Let's recreate some different data sets. In this case, we'll recreate the ones for the administrative level 1, the regions of Kenya. The command is exactly the same. You don't have any difference for the number of units that are inside the shapefile, because they're stored, as we said, in a tidy data set in the database, which has each of these elements as a row. So this has, I think, 8 regions of Kenya. 1, 2, 3, 4, 5, 6, 7, 8. Yes, I remember some things. And we'll store them, again, very carefully named to correspond to the name of the shapefile here. And then we separate carefully the database and the coordinates for that map so that we don't confuse them down. And to put the base map on the Stata graphing window, we take very simple steps with 2 commands. We use the data set that contains one row for each of the regions that we want to graph. In this case, it'll have 8 entries in this DTA file in the working memory of Stata. And when you call the spmap command with the ID variable, again, this doesn't matter at all, so I just keep it consistent across everything. I guess there may eventually be a place where you want to change that, but I don't know why. When you call spmap using the base map coordinates, it corresponds the IDs from the database to the ones in the DTA file, and it can draw those 8 regions and their boundaries independently. So these are now 8 objects in the graph window. Since they came from the same area, their boundaries line up nicely, and they share the boundaries. If you're combining shapefile information from multiple sources, you'll end up with different IDs. You can do it. You can, for example, append these things once you actually look at them and start playing with the coordinates and database files yourself to make more complicated maps. For example, if you only wanted 2 or 3 of these, but you need to make sure that those are coming from either compatible sources that have that will line up or are separate in the case of, in plenty of cases, for example, stuff that you measured yourself, farmland being a very common example in the agriculture work here. So you get this. Again, a very simple Kenya, a Kenya that we all know and love, but one that starts to tell us more information about where things are. This is just a bigger version of it so people in a crowded lecture hall can follow along. And now we can talk about what information we want to display on top of that base map. So we can do 2 things. We can calculate information directly about the elements of the base map. So in this case, either about Kenya as a whole, which is going to be a very boring map of 1 color, or we can calculate characteristics about the regions that we're displaying and do things like color code them in the base map without any additional geographic information. So we could calculate poverty, we could calculate crop yields in different plots. We can calculate population, we can calculate population density. When you start to get a pretty detailed base map, for example, if you took something like US counties, which is the most popular one, you'll get maps like the ones that you see on the New York Times all the time. All that is a base map with information by county, displayed with different types of shading. So that's something that you can already do with just 1 line of code here in Stata. If you want to add more things on top of that, as I showed earlier, areas within the base map, lines on top of the base map, right? Roads crisscrossing the counties, for example, bodies of water, cities, urban agglomerations, households in your survey. We can put those on with additional options to this command. So we're not actually ever going to add any more commands. We're just going to add options or other inputs to the spmap command. So you're going to have to be very neat in your static coding so that you can tell where these different things are coming from. And you'll see a quite long command by the end of the session here. So you can, on the base map, work with any attribute that's at the same level of observation as the base map itself. So in this case, I'm going to make something very boring because I don't actually have additional stuff. And I don't want to get out of the process of merging data at this level. I'm just going to make a fake attribute. I'm going to call it fake attribute, and it's just the same as the ID. The reason I'm doing that is to guarantee that's going to be unique for each one. So we'll have 1, 2, 3, 4, 5, 6, 7, 8 will be the values of that fake attribute. And since we're going to put it on the base map, that attribute simply enters as an argument to the spmap command. Since those are the fundamental elements of the map that spmap is putting up using the coordinates data set, we can control them through direct options here. Here, what we're doing is specifying 4 color breaks. So 1, 2, 3, 4, 5, 6, 7, 8 will be colored according to the scheme that I've entered here. It does want you to be pretty explicit. It's not going to go ahead and make, a smooth rainbow for you. Although a lot of the recent advances in Stata color commands make that quite easy by using things like transparency to create smooth gradients, kind of by cheating. And what you see is that you get, with this information only added to the command, you're going to get the base map with the coloration according to the attribute that you've created or merged into the data. Are there any questions to this stage? This is pretty much the most fundamental use. Like I said, this is all you need to do now to get on the front page of the New York Times. If you do this cleverly with interesting information. And so this is enough for a large part of the work that you need to do in a lot of cases. The hardest part is organizing the data and the command. When you're merging stuff on, you have to be very careful with the names of regions or countries, for example. That's the biggest place that data loss happens and the biggest place where it takes manual work to actually make those things merge correctly, but it can be done, and it's not technically very difficult. So beautiful stuff. You can do lots of different things with this, although you typically won't need to. I always recommend explicitly setting this up and explicitly telling it what you want. Otherwise, it's not very useful. Legend is fine. That's if you want to know more about changing the legend, read the options and play around. It would take some work, but it can be done. Same thing for the people in the back of the lecture hall. So next, let's add some features. I picked Kenya for this one because it's a popular place and lots of people have data on it. In this case, I head over to the World Resources Institute and get some GIS data from Kenya. They have lots of interesting stuff. Here's the link. And we're going to get the 3 data sets that we need to make the map that I showed at the beginning of the session. We're going to take areas, right, so I said national parks, but it's not quite that. Reserves or something, I forget what's in there. There's all sorts of tourism stuff. So we get the protected areas polygons. We're going to take the major roads. When you get road data for countries, you'll often get a ton of rich detail about roads that are finished, roads that are dirt, roads that are highways, roads that are sub-units, and you can create, complex maps, again, down to very small areas if you want to do that. And we'll take the tourist campsites, which are listed out here as points. So we have 3 different types of information, and we're going to create, as I said, a map that shows all of them at the same time. Each one is going to come as a shapefile, unsurprisingly, but somewhat surprisingly, given that they are different types of information. Again, that's something shapefiles do natively that Stata doesn't do natively, but when we convert it, Stata is going to know how to handle it through the SHP to DTA and spmap commands that have been built up to do this. In all of these cases, the process is exactly the same. There's no changes, whether you're using lines, such as the major roads, points, such as the hotels, lodges, and campsites, or areas, such as the protected areas. SHP to DTA knows how to convert these into databases and coordinates for each one. So it will automatically understand what's going on in those files and store them in a standard format. So you don't have to worry about this at all. Same process for the rest. Create an ID. It can be the same for all of them. You do not need to specify this piece by piece because they're handled separately through the command, and replace them. And that's all there is to it. Again, you're getting a lot of data very quickly. So as you can see, we name them very descriptively. In this case, I probably should have actually changed these to be KEN to match the shapefile, but I didn't do that. So I would fix that if I did it here so that they would all sort together. So you actually building up, or actually even create a subfolder if you had more than one country going on for Kenya. So the organization of these files is going to continue to be the most important thing. So go ahead and do it. There's nothing wrong with long file names unless you're on a Windows machine, although I think that no longer is as binding. Let's start with polygons. We'll build up from, we'll go down. We'll start with the high dimensional objects and go to single dimensional objects. So obviously areas have 2 dimensions, lines have 1 dimension, and points have 0 dimensions. 1 dimension, 1, 2, 3 dimensions. I forget how dimensions work, but you understand what I'm saying. Points have 0 dimensions. So we're going to plot them. We're going to plot them here on top of the base map by adding a polygon to the spmap command. Again, you can see from the way that I've set up the command that this is all one command. There's no second command happening here. And organizing it is going to be important when you try to make edits to the map. All of the information for the polygon are going inside a single option called polygon, which starts here and ends here at this close parentheses. You specify its data just the same way as you specify the geographic data for the base map. And here, since it's a polygon, you can specify very easily a fill color. And then typically I don't want any outline color. You can, again, reference the help file for all the things that you can change. There's plenty of reasons why you'd want to do different things with these options, such as have an outline but no fill, blah, blah, blah. You can imagine all the different maps you can create, and the thing will tell you how to do it. As I said earlier, it's very easy to be loading incompatible data. As you can see, there's a lot of places on this map where things are probably intended to line up better than they do. GIS measurements are extremely precise and very easy to get very slightly wrong. So don't take these as, the absolute authority on whether things actually are in a precise place. If I have a household in this tiny little corner of the southeast, it's probably not real. It's probably part of that park. So you can check things like that pretty closely. But this isn't that bad. I mean, they roughly line up with the boundaries that we want to see. I don't have too many parks in the ocean. Maybe I do. Maybe this is a marine reserve out here or a beach. Who knows? But they work. Second, we're going to add the roads. You'll see one easy trick here to make the roads stand out is the same stuff that works on graphs. I've actually changed the outline color of the base map to gray to let it be lighter against the features. You can happily vary that. You can happily do things such as make this line bright red or make it thicker. You can color them by the quality of the road. So for example, I could add unpaved ones here in a brown or something, and I have examples of that I can, if I can find them, I can show you later. Similarly to the polygon, the line is created simply by adding a line option to the spmap command. Here I've dangled the closing parentheses so you can see exactly where everything is. This is the default. It's a solid black line with the same width as the base map, and it only requires the line option and the data pointer for the location of the coordinates for the line. Pretty straightforward. The points are slightly pickier because you are loading two-dimensional data and you have to spend a lot of time specifying exactly that. You do need to feed it the coordinate points. If you used SHP to DTA, there'll be X's and Y's, like this underscore X and underscore Y are the latitude and longitude. The other way around, X is longitude. X is longitude, Y is latitude for these points. If you're bringing in your own stuff, such as survey data, you'll need to get longitude and latitude, the other way around, longitude and latitude, yes, in here. You need to specify all the regular materials just as if you're doing a scatter plot, because that's all that's truly being generated at the end of the day. And you get this map. So that's it. It's a very straightforward technical process to generate simple maps. I don't have additional stuff prepared to go into further detail since this usually takes a little longer with everyone following along. But I'm happy to go through now for what I've probably only used about a half an hour. It's 10 o'clock. So I can go through for easily another half an hour with anything that anyone wants to have request. I see one question already in the chat, which is great. So please take a moment to think about things that you want to ask, things that you want to know. There's an infinite amount of stuff. I can go through the help file. I can go through maps I've created. To answer to Javier here, yes, you can color points differently by category. To do that, you will be able to specify a variable that creates the categories. And to do that, we're going to start needing to get into actually editing the data files that are here. Yes, I can go through the last part, meaning what all of these maps, the full map here. Just I'll come back to that. So to color things by category, you will need to start opening up these coordinates data sets, since these aren't actually referencing the database data sets. So why don't we just do it? And it'll be a fun experiment. I'll start everything from scratch here. So yeah, so for Claudia, I'll go through the last part here. We'll get online. And I'll actually show each of these pieces so we can just walk through it. So here's this. They clearly have certificate issues. I'm going to push through them. So here is the data set. I want to allow this. This is the way that it's when you load it from there. So let me go ahead and just pull up desktop. And then here are the data sets that come inside that download. It's the materials for all, like I said, 5 administrative regions, license information about whether you can reuse them. You cannot, so if you're publishing data, you're not allowed to redistribute them. You can just include a citation to get them and the information for users to get them. So you can't include that in a data release when you're making a reproducibility package, for example. What do I want to do? I want to open Stata. Let's just go here. Is this, if it's not large enough for anyone to see, just let me know and I can zoom in always on the text. Um,
Ben, could you actually
yes.
just zoom in a little bit? You can see it, but it'd be clearer if you can zoom in.
Is that better?
Yeah. Thank you.
Great. And I'll try to keep it straightforward. So how did we write the SHP to DTA command? Is, where's my presentation gone? Away from, did I close it? What's wrong with me? I need to follow along. If I find my own won't work, this would be a lot easier. So we use the, so again, we use the administrative shapefile that we want. Then we specify the two files that we're going to create. The ID is always the same, and replace, and then we should be able to run. It doesn't like it. What have I done wrong? Gen ID. Then inside the data, we now have these files. So we can, for example, very quickly show you what's in there. And I did actually name it weirdly. So here's what you see inside that database folder. Like I said, it has 8 entries for the 8 provinces at this level. It has their names. So if you want to add new information to this data set to graph, we're going to merge on using either the IDs that we created, which unfortunately aren't going to be reliable across different sources, or using the names, which are also not going to be reliable across different sources. So merging data in here is going to be painful, but you will always have this authoritative list of what to merge things to, so you can at least start from there. Next steps. We're going to create the lines, which I need to go get. Let's use my own resources. Here's the roads. Same type of files here, although you just have one shapefile. Again, all of this other stuff you can ignore, but you cannot delete because it does actually get read in to create the information. Namely, the dbf, right, is the database file that's being read by this command, so it knows it's there and it expects it to be there, even if you're only referencing the shapefile in most cases. So then here we're going to do let's be lazy and just put everything in the same folder. We copying the name directly from the way that it's given to us for now, although we can change that in the sure. Here's the roads. If you open up the roads data set now, for example, you actually get not just one large thing, but you have several. This one's not a very good example. It does have 2 rows, and you can see that from the Ken road ID that's put here. Actually, the other way around. ID. So you actually have a large number of road segments that make up this material. And if we load the, I saved it incorrectly because I wasn't paying attention. So if you open the coordinates, you'll see that each of these segments has various pieces. So the first one has 3 line segments making up a road. The second one has 35 line segments making up the road. And each one is ID'd, right? Because you created that ID variable. So you can start to load characteristics into that. So for example, we can do that by looking at the database for the roads. Again, not super interesting, but once you start adding, you can add characteristics by merging into those data sets. And it's easier to do in coordinates, so I'll load coordinates. We can change them based on their color. So let's see, tourist. Same type of information. Still being lazy. So now you actually see that these databases come with more information, such as, for example, different categories as heavier expression, or they can be added on through manual processes. So you can go ahead and edit these data sets. Let me see. I think I need to do it in the coordinates one. So it doesn't have the information. We always go back to the help file to understand how we need to do it. Pull up those sub options for the point. So let's, again, create this very simple graph. So let's just put the campsites on there so we can look at this one thing at a time. So again, we're going to use the database for the base map. And spmap using the coordinates. And this should give us so as we said, and we'll add those points. We get the default dots. Error file.pol. let me look at that. Yes, all of the questions that are in the chat are very good. Maria's question is great. If their geographical codes are different, yes, you need to modify your codes to match the ones in the shapefile. You're always going to treat the shapefile database that you open as the master source for the IDs, and everything should be harmonized to that, whether or not you agree with it or use it in your data collection. If you're plotting data at a municipality level but only want to plot region or state lines instead, that's a great question. So let me go ahead and show you how that might be done. We'll just have fun here. So for example, I'll make the level 2s, which I think are the counties. And you'll run out of ability to do this stuff very quickly with Stata, but you can do it. So, and we're going to cheat on this one. We're going to run it the other way around. We'll make the base map to level 2s, and then we'll plot level 1s on top of them. So I think this is the question that Juliana is trying to answer. And let's just see if we can make it work to start. You can't see it, but we do actually have both here. So let's figure out how we would do that. We would just make the base map. I wonder if it takes none. Do the same thing that I showed in the demo here. Take none. That's what's wrong. See, it can take a minute, but complicated little boundaries here. Anyway, getting closer. You see, at least we've got the level 2 stuff here. Don't know why this is not coming out correct. Or is it? Because here we have boundaries. Something's going wrong here, but you can see that you basically can get sub detail without showing it under the map for the region. A little more playing around, and we would be able to get that working. So that can be done. Directory issues, great. Most of the time, attributes need to be transformed from raster data. If you need to do stuff using raster data, you definitely need to start by going through more advanced software. Stata is only going to take things that are already in shapefile formats. If you need to join attributes between rasters and regions, you're going to need to do that in software, specialized software. But once it's done, you can, presumably, hopefully I'll do that one time. Can I show an example with the grid overlay? No, I can't, because that's a pain. That's a pain. You can work that. You can work that. Although I can give you resources to do it. There's a nice old presentation by Maurizio Pesati, which goes through some of this stuff in detail using Italy. So you can see this kind of material can get set up. There's lots of great examples for this case. Here is railway junctions, and I thought this was the one where he did the gridding. Maybe it's not. Google remains is obviously the most important thing that there is. I was sure there was a point where they made grids or something in here. No, no. No, I can't find the gridding at the moment, but they can't be. Map tile is a nice one that sits on top of this and can do something like this very easily. Okay, so that's the broad setup. Does anyone want to see anything more done interactively here, or are we understanding how this is coming together? We're now at an hour, which is the usual runtime, so happy to take additional questions. Up if people are satisfied, share the presentation. Roshni, what are you thinking?
Sorry, I did not hear your question. Did you say wrap up the presentation or?
Yeah, if people are satisfied, if I think I've gone through most of the questions that came in the chat and showed the stuff here. I can show everyone my cat because she is interested in what I'm doing. She's recently joined our team. So she says, hello, this is Penelope.
There's one more question in the chat as well. What part of the code did the colors for the categories?
I did not do the colors for the categories yet. To do that, that's a great question that I did need to finish up. So here, when we're in the help file, we go to the point sub options whenever we need to do it because we can never remember how to do it ourselves. There's a by command here. So let me remember if those need to be added to the coordinates data set or not. So let's check by using let me go back and reconfigure this so we use the points. So again, we can make the points very quickly. Yes, we can. Let's just stick to one so we don't cluttering ourselves up. Beautiful stuff. You can see you can trick it by using a different database with the different coordinates as long as the IDs line up. You can do some hacky stuff, but I don't recommend it. Okay, to color the points, we want to use a by command. Then we want to know what our variables are. So let's look at the thing that might need to be added to the coordinates itself. Let's see. That doesn't have the information. So we go back and look at the database. And we see that we have a by characteristic, say, for type. So we'll try and call by type. And if that doesn't work, we'll do some data manipulation. It bounces. So we do, in fact, need to go back and merge that. So we'll do exactly what we think we would need to do, which is use the coordinates. Merge them onto the database and resave the coordinates. You see the coordinates can actually be something much more like survey data with lat long than something that's kind of like special. And why is that? Underscore ID because I really like to be mean to you in this world. And I really like to call it the other way too. Let's just cheat. And then now the coordinates have the type variable. Or they don't. Probably wants it to be categorical. Certainly does. Now let's try it with the categorical. And you probably have to give it instructions on what to do with it. So it's actually plotting it this time. Let's do some colors. Or shapes, colors. Blue, red, green. Yes, and once we tell it what to do very explicitly, we actually get the coloration of points by some characteristic. So there's the answer to the question that got us started on this crazy tangent. As you can see, even if you really think you know what you're doing, like I do, it still takes some time to put this together. What did we take? About almost 15 minutes or half an hour to get this very basic rainbow popping up. But once you do it, you can get a lot of useful stuff out. If you can use ArcGIS and Stata, is it spending time to learn mapping using Stata? The reason, I mean, if you can use ArcGIS and you're able to script it, so that you can run these things really quickly, go ahead and use ArcGIS. But you won't be able to transfer that code to people using Macs because ArcGIS isn't supported on Mac. You may not be able to change parameters really quickly without flipping back and forth between code. So you may not be able to do this for things where you need high frequency runs, data is continuously updated coming from the field, and so on and so forth, right? ArcGIS is just, it's not a statistical scripting language, so you'll have to flip things back and forth in Stata or call them through the shell in order to get them to work in a fully automated and reproducible environment. Whereas with Stata, you can typically do stuff the other way, like I said, except for calculations and stuff, which you'll typically want to do one time. The do file that I'm working on, I'm happy to share, except it's pretty much exactly, yeah, Roshni, we can send that around, right?
Yes.
Great. I mean, it's just this basic stuff. It's very similar. This part is already in the presentation. This part will be the useful new part, which adds the by categories to the points. So let me clean it up a little so it just runs top to bottom. And obviously, because of the license, I cannot share that geographical data when we send it around. Okay. Okay.
Then there's one more question in the chat from Javier.
Yes. Do we have other resources for working with spatial data? We should. For anything, I don't have stuff specifically, but I know we have resources for our. I'm just not very fluent with them. I would recommend to check out the DIME wiki, dimewiki.worldbank.org, and see what we have posted up there. We're in the process of revising stuff for the new materials, so we'll make sure that we have any spatial information on that website, which has not only this, but all of our resources and information for all sorts of topics. So I should be able to put that in the chat.
And to add to that, we do also run a training course in R, which includes a session on spatial analysis. in R. I think this is the only sort of preset training that we have available in Stata, but if there's kind of specific questions or requests, we're always developing further continuing education sessions. So feel free to send those our way. We'll put the email for Dime Analytics in the chat as well, and we welcome suggestions for future sessions.
Great. Okay, then with that, I think we'll wrap up. As always, feel free to contact us directly through the email that Maria's put in the chat, and anything that we can help with or develop and provide, we're super happy to do that. So thank you, everybody. Roshni and Maria, do you want to close up with